Today, we're going to talk about properties of quadratic functions in standard form. Okay, so we are starting Chapter 5 here, Section 5.2. A couple of key words here. What's it mean to be a quadratic? We just got done dealing with polynomials. What's a quadratic? Huh? So quadratic, what's that? If we, let's say we had a quadratic polynomial, right? What would a quadratic polynomial, a quadratic binomial look like? Yeah, it's a what exponent? 2. So for example, like a quadratic binomial would be like x squared plus 2. That's a quadratic binomial. So again, we're talking about quadratics this chapter. So dealing with x squared. And then what's it mean to be in standard form?
Everything in order.
Everything in order. So the highest exponent to the lowest exponent. So a quadratic trinomial here would be like x squared plus 2x minus 3, something like that. Okay, so that's in standard form. So we're talking about quadratics, functions of them in standard form, section 5.2. Some key vocab terms here. The first one, quadratic function. Quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. So again, it's ax squared plus bx plus c. Notice as in standard form, quadratic term, then the linear term followed by the constant term. A, B, C are the coefficients in front. A parabola. This is what we're going to be talking a lot about today. In this whole chapter, we're talking about parabolas. A parabola is the shape of a graphic quadratic function. Does anybody know what letter the shape looks like? The letter. A parabola. If you look up there at the poster on your right, there's some examples of parabolas. What letter does it kind of look like? A U. Yeah, a parabola is a U or an upside down U. Or you call that an N, I guess, sometimes. But parabola is the shape of a graphic quadratic function. Also, the set of points equidistant from a point F called the focus and a line D called the directrix. Okay? So we're going to talk about parabolas. We're going to be graphing parabolas today. And then I have axis of symmetry, key one today. Axis of symmetry is a line that divides a plane figure or graph into two congruent reflected halves. When you think of something that's symmetrical, what's that mean to you? What's the same? On both sides, yeah. So, for instance here, a parabola is symmetrical. So again, that'd be like the axis of symmetry right in the middle there. It is perfectly symmetrical. Just like if you think about like your body, you think about your face and your body, it's perfectly symmetrical, left to right side. Okay, that'd be symmetrical, symmetry. Standard form, we talked about this already. But standard form, ax squared plus bx plus c, where a, b, and c are real numbers and a cannot equal 0. So standard form puts it in the highest exponent on down. And then last but not least, we're going to talk about minimum and maximum value. Minimum value is the y value of the lowest point of the graph. We'll talk about this later, but the minimum value would be something like this. So it's the lowest point of the graph. So if it's a minimum value, that means my graph's going up because there's the lowest point. Does that make sense for everybody? You see how my graph goes up, there's a low point. And then a maximum value means my graph's going down. My maximum value is the highest point. So again, the maximum value, think about it like a ball. Let's say you go to the hoop or go to the basketball courts and you shoot a basketball. The highest point, that would be like your maximum value. Okay, so we have minimum and maximum values. So here's what we're looking at today. Okay, you can use the properties of a parabola to graph a quadratic function in standard form. Some key parts here. If A is greater than 0, my parabola is going to open upwards. If A is less than 0, my parabola is going to open downwards. So that's kind of a key point to recognizing what my parabola is going to look like. If it's greater than 0, so it's a positive number, it's going to open up. And if it's less than 0, negative is going to open down. If you look over here, here's a poster on the wall. See how there's a negative up front? The negative showing that my parabola is going down. If you look over here, here's some examples of positive ones. So you have a positive 1/5, positive 2, and notice your graphs are going to go up. Okay. A, B, and C. Again, A, B, and C are my coefficients. So if you look here, it says, a equals negative 1, because it's negative x squared. B equals negative 2, because it's negative 2x. And C equals 2, because C is my constant there. Okay, and we found out A is less than 0, so my parabola is going to open downward. Now let's think about it. If my parabola is open downward, will I have a minimum or a maximum value? That purple dot there, would that be a minimum or a maximum? That'd be a maximum because it's going down. That means I'm going to have a maximum value. Okay. From here, this is the process for which we're going to graph it. The first one is the biggest step. You're going to do this a lot today. We need to find the axis of symmetry. The axis of symmetry is key in a parabola. Why? Because from that line, I only have to do half the work. Okay? Because the left side would be perfectly symmetrical to the right side and vice versa. To find the axis of symmetry, we're going to do what is negative b over 2a. Notice b comes from my b term, a comes from my a term. So I do negative b over 2a, I evaluate that, and I get an axis of symmetry of negative 1. So at x equals negative 1, I draw an axis of dotted line there to show the axis of symmetry. From there I find the vertex. To find the vertex, I take my axis of symmetry and I plug it in for x to evaluate. So I take my axis of symmetry, plug it in for x. I get 3. That is my vertex, negative 1, 3. Oop, bad dot. There we go. So negative 1, 3 is my vertex. After that, I'm going to graph the y-intercept. The y-intercept is always, always, always my constant. That is true for any equation. The y-intercept is always going to be my constant. So y-intercept is 2. So 0, 2 is the point on the graph. And then this is key. Because a parabola is symmetrical, I can reflect that coordinate and put it on the other side of the line as well. Because it's symmetrical, I put the exact same coordinate from the same distance on the other side. That's using the symmetry, and then I can sketch the graph. And that's the process we're doing today. Alright, so again, a lot of algebra in this, as in we're going to kind of plug some information in and work on it. So let's look at number 1. It says use the properties of a parabola to graph f of x equals x squared minus 4x plus 3. First thing I want to do is I want to identify my a, b, and c terms. Jake O'Connor, what's my a term going to be in this function right here? A is 1. What's b, Jake? Negative 4. And c? 3. Nice job. 1, negative 4, 3. So now I look at it. The graph's going to open which way? It's a positive 1. So my graph's going to open up or down? My graph is going to open upwards. So because my graph's open upwards, do I have a minimum or a maximum value? Somebody said it. I'd have a minimum value. Great. Okay. Number 3 says find the axis of symmetry. So axis of symmetry is negative b over 2a. So what is b here? B is, what's my b term? Negative 4. So I have negative 4 over 2 times, what's my a term? 1. 2 negatives give me a. So negative 4 gives me positive 4. 4 over 2 gets me, what'd you say? 2? So there's my axis of symmetry right there. It's at x equals 2. Now I need to find my vertex. To find my vertex, I take 2 and I plug it in for x. So that gives me 2 squared minus 4 times 2 plus 3. What's 2 squared give me? Algebraically, 2 squared is 4. 4 times 2 is 4 times 2 is 8 plus 3. So what's 4 minus 8 plus 3 going to give me? Negative 1. So my vertex is located at 2, -1. Right there. Oops. I guess I should write that down there. Next, what's my y-intercept here? My y-intercept is 3, or the coordinate 0, 3. So I plot 0, 3. Now, because of the axis of symmetry, what else can I do? Can I plot the coordinate on the other side? Yeah. Notice it is 2 away from the axis of symmetry. So I'm going to go 2 away on the other side. Right there. Oops. And there is an example of my parabola. Let's try another one here. Now notice this is the process for which it is best to graph. First thing, as always, find and graph the axis of symmetry. We've done that. -b over 2a. Take your axis of symmetry and plug it into the equation to get my y. That gets me my vertex. Next, you'd want to find and graph the y-intercept. That's my constant. And its reflection. And then step 4 says evaluate the function for another value of x. You get to pick one more value of x. You get to pick another value of x. Now, when I go to pick it, there's obviously going to be some values that are better than others. What's always a good value to pick? What's always a good value of x to evaluate for? 1. 1's always a good one. 2 is always a good one. Would 0 be a good value to pick? I can't be 0. Why, Drew? Because the 0 actually gets me my y-intercept, which is my constant. So you can't pick 0 because it's already used, because that's always going to be my constant or my y-intercept. And then last but not least, I'm going to sketch the curve. So let's look at number 7 here. I want to graph y equals x squared minus 2x minus 3. First step, axis of symmetry. So I have x equals -b over 2a. As you look here, what's a going to be, Joe? What's a? Joe Daniels. A equals 1. What's b, Joe Daniels? And what's c, Joe Daniels? So I'm going to have -2 over 2 times 1, right? So what's two negatives give me? A? Positive. So positive 2 divided by 2 gets me 1. So my axis of symmetry is right here at x equals 1. 2. Plug x in. So I'm going to take 1, I'm going to plug it in for x. I get 1 squared minus 2 times 1 minus 3. What's 1 squared? 1. 2 times 1 is? 2 minus 3. What's 1 minus 2 minus 3 get me? -4. My vertex is 1, -4. So there's my vertex. Step 3, y-intercept. What's my y-intercept here in this problem? 0, -3. After I do the y-intercept, then I need to do its reflection. So I go to the other side. 4, I need to pick an x value. What's a good value to pick here? Now, 1 would be a great value to pick. However, what's 1? That's our axis of symmetry. That's my vertex. Can't pick 1. What else can I not pick? Can't pick 0. That's my y-intercept. Can't pick 2 because that was the reflection. So, what would be the next best value to pick? Let's pick x equals 3. I'm going to pick x equals 3. So I take 3 and I plug it in for x. So I have 3 squared minus 2 times 3 minus 3. 3 squared gets me 9. What's 2 times 3?
6.
So 9 minus 6 is?
3.
Minus 3.
0.
So the coordinate is 3, 0. And then I go and I plot the reflection. And last but not least, I'm going to sketch the curve right there. Huh? There you go. Again, kind of a process here, but if you follow the steps, it's not going to be too bad. Let's try number 8. It says graph y equals 2x squared minus 4. First thing is x equals negative b over 2a. As you look here, what's my b term going to be? What's b going to be? B is 0. Does everybody see why it's 0? Everybody like saying 0x, wouldn't it? It's not there, so it's like saying 0x. So if it's 0, I'm going to have 0 over 2 times 2. What's it going to be? Yeah, my axis of symmetry is going to be 0. Next, I need to find my vertex. So to find the vertex, I plug 0 in. So what's 0 squared? Times 2? Minus 4? 0, negative 4. But if that's my vertex, what's my y-intercept then? What is my y-intercept here?
It would be 4.
Isn't it the same thing? It's the same things. What do you notice here? If my b term is 0, my y-intercept is my vertex. So now in step 4, I need to pick 2 x's. I need to pick 2 x's. What are some good values to pick? Okay, negative 1 and 1 give me the same value. I'm going to pick x equals 1, and I'm going to pick x equals 2. So if I plug 1 in, I get 1 squared, which is 1, times 2 is 2. 2 minus 4 is negative 2. So I get 1, negative 2. Plot the reflection. And then I plug in 2. 2 squared is 4. 4 times 2 is minus 4. So I get the coordinate 2, 4. And last but not least, I'm going to sketch the curve of my parabola right there. Nice job. Take a couple seconds, try number 9 on your own. All right, I'm slowly going to start working through this here. So 1, you should have your axis of symmetry. X equals negative b over 2a. Well, b is 0. So my axis of symmetry would end up with 0 over 2, which is going to be 0. So axis of symmetry is right down there on the y-axis. 2, I need to plug 0 in. When I plug 0 in, I get my vertex, which is 0, negative 2. Because 0 squared is 0. 0 minus 2 is negative 2. Vertex down here is 0, negative 2. 3, that's my y-intercept. Well, what's my y-intercept here? Yeah, my y-intercept is the same thing as my vertex, 0, negative 2. Well, I've already graphed that. So 4, I need to pick some values of x. What were the best values of x to pick?
1 and 3.
I mean, I could have picked 1 and 3, you bet, but I would have done what?
1 and 2.
I would have done 1 and 2. I could have done 3, that's no problem. I also would have done 1 and 2. So when I plug 1 in, what do I get out? 1 squared is 1, 1 minus 2 is negative 1, right? So I get 1, negative 1. Plot that one, plot the reflection. Then I plug in 2. 2 squared is 4. 4 minus 2 is 2. Give the coordinate 2, 2. And I plot that there. And that is my parabola right there.
Wait,
Is that what yours looks like, Beast?
Yeah.
That boy. Take a couple seconds. Try number 10 on your own. All right, so let's walk through number 10. First thing I do is I need to find axis of symmetry. X equals negative b over 2a. Okay, what's the axis of symmetry going to be? Axis of symmetry is going to be 2. So from x equals 2, I draw my dotted line. Next step was to find the vertex. Katie, when I plug plug 2 in, what do I get back out? You get 2, 6. Is that right? I believe so. Now what's key on that? When you plug it in here, it's 2 squared, 4. Then you tack on the negative, right? So you get negative 4 plus 8, which is 4 plus 2 is 6. So my vertex is up here about 2, 6. 3, I need to do the y-intercept. What's the y-intercept, Katie? Y-intercept is 0, 2. So I plot the y-intercept. Then I need to plot the reflection over there. Now I need to pick one more value of x. Katie, which value of x did you pick? You picked 1?
I didn't pick 1.
You didn't pick 1. Okay. Now let's think about it here. I can't pick 0, because that's my y-intercept. Can't pick 2, that's my vertex. I can't pick 4, because that was the reflection. What's a good value to pick?
1 and 3.
1 or 3 would be great values to pick. Now, would 1 or 3 be the same value technically? Because they're on either side of the...
Yeah.
So I'm going to say I should just do 1. X goes 1. So when I plug 1 in, 1 squared is 1. Tack on the negative, you get negative 1. Plus 4 plus 2. When you plug 1 in, what do you get back out? 1, 5. There we go. There's my curve right there. Nice job. Okay. We're going to skip number 11. And we're going to do the last thing. We're talking about maximum or minimums here. Okay, now we're talking about this a little bit. Remember, to tell where it's a max or min, we look at which way it's opening. So, for example, if it's negative 2, which it is here, a is negative 2, that means my graph's going to go which way? Is it going to go up or down? That means my graph's going to go down. And because my graph's going down, that means I have a maximum value. Okay, again, it's like if I toss the ball up in the air and it comes back down. The highest point, that's the maximum value. To find the maximum value, now again, if you think about it here, if I were to draw this right here, anybody want to take a guess where that maximum value is located at? We've been finding it this whole time. It's the first couple steps we do. The maximum starts with a V. Axis of symmetry is also the vertex. Okay, the maximum value would actually be the y value of my vertex, which is found using the axis of symmetry. So to find the maximum or minimum, all I'm going to do is I'm going to find the vertex. Okay. Ooh, man. Edited is slow there. So I'm going to find the vertex. When I find the vertex here, I end up with 1, negative 1. Well, the maximum value is going to be the y-coordinate. So my maximum value there is negative 1, which is my y-coordinate. And then I want to identify the range. Well, the range is my what values? That is my y values. Domain is my x. Range is my y. So if it's a maximum value, that means my values are going down, right? So if it's going down, that's going to be y is less than or equal to that maximum value. So y is less than or equal to negative 1. All other values must be less than or equal to that maximum value. On the flip side, if a is positive, that means I have a graph that goes up. And if the graph goes up, that means I have a minimum value. Okay. Same thing, I want to find the vertex. The vertex here on this one was negative 2, negative 11. I should say min. Okay. The minimum value is located where that y-coordinate is. Now because my graph is going up, instead of y is less than or equal to, now I'm going to have y is greater than or equal to. Okay, because my graph's going up, I'm taking all the values that are larger than that value, because it's a minimum value. So the same thing here, we're finding minimum axis. We're just going to start up, we're just going to find the vertex. Okay, and we're looking at the y-coordinate. So let's look at number 12. F of x equals 2x squared minus 8x plus 9. It's positive 2. Does that mean my graph's going to go up or down? My graph's going up. So will I have a minimum or a maximum value? I will have a minimum value. I need to find the vertex now. So negative b over 2a. So I have negative 8 over 2 times 2. That's going to simplify to get me positive 8 over 4, which is 2. I take 2 and I plug it back in now. So 2 parentheses 2 squared minus 8 times 2 plus 9. Well, order of operations says 2 squared is?
2 squared is 4.
4 times 2 is?
8.
8 times 2 is?
16.
So 8 minus 16 plus 9 is?
1.
1. So my vertex is 2, 1. Which means I have a minimum value at 1.
1 be 1.
Ooh. My minimum value is located at 1. Okay, so if it's going up from there, it's now going to be y is greater than or equal to 1. Because it's the minimum value at the positive 1 there. So y is greater than or equal to 1. Let's look at 13. A is negative 3. That means my graph's going to go up or down? My graph's going down. If it's going down, we'll have a minimum or a maximum? I'll have a maximum. I need to find the axis of symmetry to find the vertex. So negative b over 2a. So negative 6 over 2 times negative 3. What's negative 6 over 2 times negative 3? Positive 1. I plug 1 in. So negative 3 parentheses 1 squared plus 6 times 1 minus 4. Well, what's 1 squared? 1 times negative 3, negative 3, plus 6 minus 4. Negative 3 plus 6 is 3 minus 4. What is it? So my vertex is 1, negative 1. Which means we'll have a max or minimum value at negative 1. As a maximum. So if it's a max, I'm going to say y is less than or equal to negative 1. And that's it. So again, a lot of process today. Here's your assignment.